So I think we are all set to go. So thank you very much for joining us. This is one of the most exciting workshops that we have today. This is Mad Science, STEM experiments you can try at home. So I am going to hand it over to Mr. D. Thank you.
Well, hello. Ms. Brito, I'm showing on my Zoom that I only have 3 participants, you, me, and someone else. Is it correct that on Whova there's a bunch of other people?
There might be, I'll go check back over there, but we're live on our YouTube channel as well as on our Facebook and social media. So there are lots of people watching. So we
Great.
are good to go.
Let's go for it. So hello, everyone. My name is Mr. Dufour. I'm here with a little bit of science for you today. Just a little bit of background about myself. I am a 17-year veteran high school science teacher. What that basically means is they've allowed me to play with some pretty fun toys for 17 years and try not to get in trouble. That's what science teachers do. I have been teaching physics, which is the study of how things move, chemistry, which is the study of how liquids and chemicals and stuff interact with each other and make cool things go fizz and blow up and stuff. I teach field botany, which is the study of plants and how they grow and how they reproduce and what kinds we have around. And I teach a bunch of other courses like astronomy, which is about space, meteorology, which is about our air and our clouds and our weather. I teach geology, which is about rocks and minerals. That class really rocks, let me tell you. And I teach oceanography, which is about the oceans. And right now, what I wanted to do is give you some science that you can take home and have some fun with. You're approaching, for some of you, April vacation. Some of you might have just had vacation or might have some coming up. You can do this during the summer, but we've had a pretty weird year in terms of school. I'm sure everybody's in the same boat. So I didn't want to bog you down right now with some science lessons, like here we go, we're going to talk about this science and do this stuff. I wanted to give you some fun activities you can do with your parents or teachers. Here's some fun stuff you could do with the elementary school kids. A way to turn things that we know how to do into a science experiment or an activity. Some things that I did as a child, some things that we even do with the high school kids that are just for fun. And I really wanted to show you kids how science can be fun. But I got some questions for you to begin with, because I've got some things that are really heavy on my mind right now. And I'm going to ask some questions, and I wanted to do a show of hands, but I don't see any of you, so we're just going to go with it. I'm going to pretend like the answers that I get are what I imagine they're going to be. So number 1, very important question. This is a life question. You need to be ready for it when you get all grown up. Make sure your parents know about it. It's very important. Is a hot dog a sub or a sandwich? That's important. I had hot dogs last night. So I'd ask you normally, if you were in my class, I'd say, is a hot dog a sub or a sandwich? And then we talk about it. You might say it's a sub because it's long and it has that kind of that bun that connects on the bottom. It's not 2 separate pieces, so it's like a sub. You might say it's a sandwich because it's a piece of meat between 2 pieces of bread. However, the National Hot Dog Association classifies a hot dog as a hot dog. There is no it's a 3rd separate group. So what did I just do there? It's a question that's flying around my high school like crazy for the last 2 years, and everyone gets very heated about it. I took a question that people want to know about. I don't know. I had hot dogs last night. I want to know about hot dogs. And I turned it into an observation and an analysis of, decision as to what I think based on what I see. Some of you might see things a little differently. Some of you might see a sub. Some of you might see a sandwich. That's the way science works, and that's what's fun about science. The big question is, how does science go into your everyday life? That's a question we ask ourselves in high school too. How do we relate this science to our everyday life? Like, for instance, the taco, another very important piece of your life to some of you. By the way, my kids no longer do hamburger and hot dog when they fold a piece of paper, because a hamburger is round. They do hot dog and taco when they fold papers. That's something for you teachers to take back. So a taco, it's a hard shell with some ground beef and some lettuce and some tomatoes and some sour cream and some cheese or whatever you want to put. How do I change that? How do I put science into tacos? Well, what if you change the shell? Make it a soft shell taco. What have we changed here? We've taken a piece of the material and we've turned it into something else, a soft shell taco. And that is a way of modifying something that I've made to produce something different. What if I take that soft shell taco and I replace the ground beef with like pepperoni, and I still have the cheese, and I replace the lettuce with like mushrooms, and I allow the soft shell to flatten out and fold down? Well, that's now a pizza. You didn't know tacos and pizzas were cousins, did you? A pizza is a flat taco, basically, with different toppings. So science comes into your everyday life in ways you don't even know about. You don't even know about all this science stuff. So what I wanted to do was give you, I have these weird setups, by the way. I'm the kind of science teacher who's all over the place in my talking and the way I look. I am looking at a clock. I have this neat setup down here, this green screen with my camera that I'm going to use to show you some things. And I have some experiments that I wanted to show some of you how to make. Things in your everyday life that you can use and wonder, why do they work like that? Why does a taco turn into a pizza when I let it go and change the toppings? Why is a hot dog a hot dog? So there are some experiments that I have lined up for you. They're not dangerous unless you make them dangerous. Safe science is fun science. You got to remember that. It's good to have fun with science, but it's got to be safe. So these are some things that I think are safe if you treat them the right way, things you can do at home, and ways that you can look at the science that go into them, but also enjoy yourself and have some fun during vacation. A way to take something as simple as oil and water and turn it into an arts and craft or turn it into a game. So let's get going. Science time. I have my desktop right here that I'm going to show you from how to build some things. And the first thing I wanted to do is something my daughter and I play with a lot. And it's something I play with in class a lot and I played with as a kid a lot. It's a very simple setup. I need just a couple of pieces of material. I need tape. I need a straw. I'm going to use a metal straw because plastic, plastic going into the environment, stuff like that. You should try to use reusable stuff as much as possible. I got a pad of sticky notes. This is good for this project. I've got some painter's tape, which I'm going to leave to the side so it's not taking up my entire screen. And I've got a little bit of imagination here. So something that's fun to do. Recently, we've seen some pretty cool things in science. NASA, which is the company that shoots rockets and stuff up into space and sends astronauts into space, does a lot of science in space. And they recently launched a rocket into space that went to Mars. You may have seen the rover, the little car that just landed on Mars, and it's got a buddy with it. It's got a helicopter. That's so cool. We've got a helicopter on another planet. I mean, who does that? NASA's like, oh, we're going to do it. That's going to be fun. So I was talking to my classes a little while ago about rockets and how they work. In physics, we talk about how things move. So one of the things we talked about was rockets and how they move. And my kids are like, Mr. Dufour, can you demonstrate a rocket to us? I was like, well, I made rockets when I was a little kid, but I don't have the stuff I needed, except for a very simple rocket called a straw rocket. So I'm going to show you right now how to make a straw rocket. I'm going to show you how to make it. Then we're going to talk about the science behind it a little bit, not a lot. I don't want to bog you down with a lot of information. I want to have fun. So we're going to talk about the science behind it and how we can change this rocket to make it work better, and then talk about how we can make a game out of it. So here we go. If you're at home watching this, not live, like later on in the future, like you're a time traveler or something, you can pause it and gather these supplies. But if you're watching it live, just pay attention and be ready, because you can gather this stuff in the future and make one yourself. I'm going to take a sticky note and make a rocket out of it with a straw, which is pretty cool. All I need is one sticky note. So to do this, I need to make my rocket I need to make this sticky note into a tube, like a rocket. A rocket is basically a big can of fuel that burns its fuel, And when the exhaust, like a car's exhaust, when the exhaust goes out one side of the rocket goes the other way. It's like two people sitting on chairs, like rolly chairs, and they push each other apart from each other. Like, you know, you've got one person here, another person here, and they push each other apart. It's like that. That's how a rocket basically works. It explodes some gas, shoots some out one side, and the rocket goes the other way. That's called conservation of momentum. Momentum's how fast you're moving. Like big cars have a lot of momentum. Small cars have a little. They're easier to stop. So to make my rocket, I'm going to take the sticky part of my what's this called again? This is called a sticky note. I'm going to take the sticky part and I'm going to put it kind of down, and I'm going to roll it onto my straw, but I'm not going to roll very hard. I don't want to roll it too tight. I want to leave a little bit of space. And this is kind of tricky. You got to get that sticky note to fold down in. Now this is the sticky side right here, because that will be the first part touching the rest of my sticky note, and it will help to hold it together. And I'm just going to roll that sticky note just like that. And I'm going to hold it in place. See how I left a little bit of gap? It can move on my straw. This is where I need my tape. And this is where a friend comes in handy. I'm going to have to do this with two hands, but I need a piece of tape. And I'm going to tape that sticky note down onto itself so it doesn't unroll. I don't want it to unroll. Oh, just like that. There we go. I didn't do so bad. I kind of messed up, but you know what's good about science? You can mess up and you can fix things and do it all over again. Whenever you're learning about science in elementary school or middle school or high school, remember that. That's a very important thing I teach my kids. There's a quote that I have on my wall that says, if it's slimy, it's biology. If it's smelly, it's chemistry. And if it doesn't work, it's physics. That's the cool thing. Science a lot of times doesn't work. It's the stuff that does work that you hear about. So I've got this roll now. See, it's like a tube. That's pretty cool. That's going to be the main body of my rocket. But I can't just launch this. There's no tip or anything. Rockets have cones to them. So I'm going to take another small piece of tape, and I'm going to find where that seam of my paper is right here, that piece that was sticking out like that. And I'm going to make sure that's in the middle, and I'm just going to pinch this flat, not hard. I'm going to put my tape on the flat side and push it over the top, just like that. So I now have a point. I can fold these in. There we go. It's almost like a pixie stick. You guys know what a pixie stick is? It's that tube full of candy, like sugar, and it's got this type end. Or a honey stick. I love honey sticks. I love the cinnamon honey sticks. Those are delicious, but they're in plastic tubes with a pinched end like this. That's the front of my rocket. So all I have to do now is put my rocket on my straw, and it needs some fuel. In order to give it fuel, since there's no chemicals or anything in here, I'm going to use something called my lungs. My lungs have air in them, and if I push air into the straw, all the air that's in the straw is going to push out this side and into my rocket. And since my rocket can release off, it's going to take off. So we're going to come back up to my classroom, and I'm going to try this out, see how it goes. All right. So here I am. This is my classroom, by the way. Welcome to my classroom. I've got my straw rocket. Trial one, the rocket as is. I'm just going to give it a nice blow into the straw and see how it goes. Okay, so it went about 10 feet away from me. You can't see where it landed, but I'm going to go get it. It's right here. Right here. So it went just a little bit of ways. But if you didn't see that, what happened was it went kind of all over the place as it flew. It flew based on just how much air I put into it. And there was no nice, smooth rocket motion. It just kind of flopped around and fell. So that's obviously not a good rocket. So second part of science is, how do you modify that? How do you make it better? In the scientific method, which is the steps in which you do an experiment, this would be called revise and redo. Redo it, come up with a new plan. So what do you notice about rocket ships? They have a body. What else do they have? Like those cool Elon Musk rockets, the spaceships, those big metal tubes. What do they have on the sides of them? They have fins, these neat fin structures, kind of like wings almost. What does my rocket not have? No wings. Let's make it better. This is where my painter's tape is going to come in. I'm going to take this tape, and I am going to peel off a piece that's about that long. And on the open end of my rocket, where I want to keep it lined up with the flatness of my rocket. I don't want it up like that. I want the flat part of the rocket down. I'm going to put my tape on the back side of my rocket right there, flat. It's okay that it's sitting up. So it looks like this. Okay, and that's the flat side of my rocket. Kind of looks like neat wings, almost like a plane. That's cool. I'm going to take another piece of tape, same size. Now this is tricky. You got to be careful with this. I'm going to put it on the other side such that I can pinch them together. I want it lined up. I want to make sure they line up with each other. There we go. It's kind of like an X-Wing now. Kind of looks like an X-Wing. If you're into Star Wars, I mean, next week, Tuesday, it's May 4th. May the 4th be with you. But it kind of looks like an X-Wing. But I'm going to take these sides and I'm going to pinch them down on each other like that. So they line up with that flat tip. Kind of made wings almost. Well, that's obviously not going to do so well like that. That's kind of, you can tell right away that that's not what a rocket looks like. I could try this, and I bet you anything is just going to go right to the ground. So my next step, where are you? Scissors. They're there. I'm going to take my scissors, and I'm going to cut from the bottom where the opening is about 1/2 inch away up to the rocket, just like that. That makes a wing. I'm going to try to do an identical sized wing on the other side. There we go. That's pretty cool. Now I have the fins of my rocket. And what those are going to do is as my rocket's flying through the air, when it starts to wobble down, the air pushing on the fins will help to straighten it. And they'll help to keep it aligned. You see these a lot. Where else do you see these type of things in nature other than rockets? You see them on the side of rockets. You see them on the back ends of planes. You see them on arrows. They use feathers on arrows to do this same thing. So obviously, if all of these cultures and people from all over the world have been using this method for like thousands of years, it's got to work, right? Well, that's the thing about science. You don't always take things for granted. You try them out. You experiment. You test it to see if it really does work. But a little hint, if they've been doing it for thousands of years, it probably works. So, all right, let's take it one more time. Now that I've got my fins on here, I'm going to put it back on my straw, and I'm going to give it a go. Here we go. Let's try to line up. There we go. Twice the distance. Give me a sec. Let's go get it. One thing about science is sometimes it happens far away. So that went twice the distance just because my rocket was able to stay in alignment. But another observation I saw, remember, science is about observing things, observing the world. I saw that instead of wobbling all over the place this time, it spun. It spun in a circle. Maybe that slowed it down too. Maybe I don't want it to spin. Maybe I do want it to spin. Maybe that's the key here. Maybe spinning helped out. Okay, who knows? The only way to know is to try again. So this time I'm going to modify this, revise and redo. Take your experiment, change it a little, see what happens. I'm going to give these wingtips just a little bit of a curl in the opposite direction to each other, kind of like an S. See this? I'm going to give it kind of an S. Just a little bit of a curl on those. And I wonder if that little bit of a curl will cause this thing to spin. Let's try it out. We'll see if this goes farther. Now, while I'm doing this, I'm trying to blow the air out of my lungs and into the straw with the exact same amount of force every single time, so that you can't say, well, the other one didn't go as far because you didn't blow it as hard, or the other one went twice as far because you blew it twice as hard. That's my job, is to make sure I stay consistent so that the experiment gets valid results. So here we go. Let's see if I can do it. Oh, I wish you could have seen that. I wish you were here. I'm not even going to go get that rocket. That one went all the way to the back of my room. And it did it in a nice smooth line, curving. It was the best one yet. So actually, I'm going to go get it so I can show it to you. Science teachers are always weird, aren't they? I know, they're weird people. So this one, when I launched it, it actually spun in the direction of those fins. It spun like this, and it went straight, in a straight line. It didn't even wobble really, it just went whoo. So now you know how to build a straw rocket out of a sticky note, a straw, and some painter's tape. Now, how do you use this for fun? Well, one thing I used to do when we were kids, we learned how to fold paper such that it became a triangle called a paper football. And you'd put it on the table and you'd flick it. And your friend would be sitting over here like this, trying to get a field goal. Well, how can you make a game like that with this? How about you and your friends play a little game where you each make a straw rocket and you set some targets up around the room? Maybe hoops that you have to get the straw through. Maybe a landing zone, like you've got to get it to land within a certain area. How are you going to do that? What are you going to change? Do you change your rocket? Do you change how hard you blow the air out of your mouth? Do you change the angle that you launch it at? That's up to you. That's where it becomes a game. You can make it like, you know, you and a friend are doing it against each other, or you and someone from class are doing it against each other, and you get 10 tries, and whoever gets the closest wins. Or you can turn it into a fun activity out on the playground. Maybe you build an even bigger one, because you might be a science person and have an even bigger straw. Oh, look at that thing. That's cool. And I already made ahead of time an even bigger rocket. So maybe you have the ability to make a bigger rocket. It doesn't look bigger on my screen, but it's thicker because this is the original straw, little straw. Maybe you have the ability to make an even bigger one. Maybe you figure out how to make one out of some type of tube, like a paper towel tube, and a bigger rocket. Maybe you find a way to do it without your air. Maybe you attach a 2-liter bottle to it and you stomp on it. Oh wait, they already sell those on Amazon. They're called stomp rockets. Or you can make it yourself and have some fun doing it. So, wow, time is flying. I have 10, 20 minutes left, and I want some time for some Q&A. So, next experiment up. Here we go, right down to the table. We are going to do something that I saw online. My daughter and I did it. It's called a homemade lava lamp. Okay. If you could pin me down to my desktop, that'd be great. No. There we go. Yes. All right. So my daughter and I were looking on YouTube for something fun to do one day, and we made homemade lava lamps, and we made them according to the directions on YouTube. And I was like, okay, that's pretty cool. It worked. You might not know how to make these, so I'm going to show you how to make them, but then we're going to twist it again and see if changing something makes it different. So, homemade lava lamp. For those of you who don't know what a lava lamp is, it's a container of water with some wax in it. And underneath is a light bulb. And when the wax is on the bottom, the light bulb warms it up and that wax gets warmer. Now, warm things tend to float. That's how hot air balloons work. That's how warm air rises from the ground to warm up the air above it. This wax, when it gets warm, floats in these globs, and they go up to the top of the container where they cool off, and then they sink, and they keep going, and it looks like lava, and it's warm. So, but the one we're going to make, I'm going to use this beaker. This is cool. You can actually see right. Let me see if I can adjust my camera so you can see right down into it. I'll show you a side view too. Don't worry. That's neat. This is a flask, actually, not a beaker. So I'm going to show you it in here. And we're going to make two. The way this works in the videos and stuff I saw is you take some water and you add it to, actually, you know what? I want you to be able to see the side view. So I'm going to ask if we can come back up to my main video, because I really want you to see the side view of this. And if I do that, it's going to spill. So sorry, guys. We're going to move the camera out of the way too, because I don't want to get that wet. And I'm now dealing with liquids and chemistry, so safe science is fun science. So for chemistry stuff, got to put on some goggles, because I don't want my eyeballs to get hit. You might think, you know, I don't need goggles for this. It's something simple, until something hits your eye, and then now you have a problem. So it's so easy to put goggles on. Plus, they look pretty cool. I mean, they do look kind of cool. So I'm going to take this flask, and I'm going to add a little bit of water to it. Now, because of chemistry, I used a special water. This is called distilled water, which means it doesn't have a lot of the stuff in it that your tap water has, like iron, magnesium. This is, well, I call it clean water. And I didn't want anything to mess with our experiment, so I used clean water. And I'm going to put some into my flask such that I have about, let's go a little bit more. About that much. Okay. You can use any container at home, by the way. My daughter and I did this in a drinking glass. It doesn't damage anything. We did it in a regular glass from our house, but I'm a chemistry teacher, so I got kind of the cool toys, so I'm going to use the cool toys. Next up, vegetable oil, or as one of my kids in my field botany class, my class about plants, called it, vegetable oil. They were reading it, they're like, what is vegetable oil? I'm like, you mean vegetable oil? They're like, oh, crying out loud, vegetable oil. So this one's hard to open, but I'm going to use vegetable oil. Now I've got to go careful with this because if you didn't know, vegetable oil and water don't mix. They have different densities. Density is a science measurement that basically talks about how much stuff is in an area. Think about it like a boat. You've got two boats on a lake. You put 2 people in one boat, you put 10 people in another. The boat with 10 people's got more people in the same amount of space. It's going to be heavier too. It might sink. Heavier things sink, or things that have more stuff in the same area, more density. Oil doesn't have as much stuff in the same area as water does. And by that, I'm talking about all the chemistry stuff, molecules, atoms, all that fun stuff. But oil is lighter than water, so it floats on top. But I'm going to be very careful not to let them kind of mix up a lot. And I'm going to pour a lot of vegetable oil in here. Hopefully I have enough. There we go. I'm going to use the whole thing. I borrowed it from another teacher. Sorry, Mr. K. If I used all your vegetable oil, I'll get you some more. It's all in the name of science. Drip, drip. Cool, got it. Oil and water, and you can tell they don't mix. You can see the layer right there where the oil and the water don't mix. Now the next part's fun. I'm going to pretend like I can see all of you, and I'm going to say, do you want red, green, or blue? My mom used to call these food coloring gnomes because they look like little garden gnomes, and I believed her. I'm going to say, oh, look, everybody in the chat chose green because green is the color of Oakmont, and that's my school's color. So I'm going to pretend like everybody chose green. I'm going to take my flask. I'm going to be careful not to get this on myself because food coloring does dye. And I'm going to drop some drops in here. Now, oh, before we go, food coloring made out of a lot of water. If I look at the box, ingredients, water, and then some other stuff. So should it go above the oil or below the oil? What do you think? Should it go where the water is or on top where the water isn't? My guess is it's going to go right to the water, right through the oil. Let's see. Bloop, bloop, bloop. Oh, there it goes. Look at that one drop. That was cool. Looked like it needed a couple drops on top of each other to get them to go down. Okay, I'm going to speed this up a little. Start doing some drops in here. Get them to go down to the bottom where the water is. Oh, I'm using up all of my food coloring, but that's okay. Cool. You can see all those bubbles dropping. That's kind of the reverse of what's going to happen. Now I need those to kind of explode a little. It looks like I have a bubble in there. It's weird. Oh, let's try to... I wonder if my straw would pop that bubble. It's almost like I've got an air bubble in here. That's weird. We're going to experiment a little by trying to pop that bubble. And look, I've got my food coloring. Oh, there we go. That's what I wanted to see. My food coloring going down and mixing with my water. Now, I need something to get the churning going. So I'm going to use a little something that we can get at the grocery store. This is where your parents get involved because it's not a dangerous chemical, but it is something that you want your parents to be involved with, or a teacher. It's called Alka-Seltzer. It has minerals in it. Minerals are things like salt or clay, stuff like that, certain kinds of clay. It's got minerals in it that fizz when they hit water. So I'm going to take this and break it up into 2 parts, just so I get more stuff in there. And I'm going to drop it in and see what happens. They're going to go down to the water. Huh. Oh, they sink below the water because they're heavier and they start to bubble. That's so cool. They're bubbling. You can't really see them in there. Maybe at the bottom. But they're starting to fizz and bubble. I'm going to throw another one in. Actually, I needed the other one for my other experiment. Are they fizzing? Let's get that straw again and mix them up. Oh, look at that. Bloop. That's kind of cool on its own. I don't even need to do anything. That's kind of cool. I get the straw, I pull some up and let it go. That's kind of neat. So that didn't work yet. I've got some fizzy bubbles coming up. Not a lot. I'm wondering if it's just old Alka-Seltzer. Remember what I said, this is live and some science doesn't work. And if it doesn't work, that's just embarrassing. Oh.
Mr. Dufour, we did have a question.
Sure, go for it.
So the question is, and I'm not sure if this actually happens, so we would definitely appreciate your expertise, but why do warm things float?
Well, I'm going to sit and let this beaker kind of do its thing and hopefully it gets going. And if it doesn't, that's going to be embarrassing. But why do warm things float? So when I tell my classes about this, this is the example I use. If you take a bunch of second graders and put them in a gym and bring the temperature down to freezing, what are they going to do? They're probably going to gather together into a group and kind of shiver a little bit, right? Like, they're not going to move around much. They're just going to kind of shiver. But if you bring the temperature up in the room to like a nice summer day, now what's going to happen? They're going to be all over the gym, bouncing off walls, playing with basketballs. That kid's got a street hockey thing going on. We've got volleyball going over. They're going to be everywhere and running around and having a good time. But if I bring the temperature back down, they're going to sit there freezing cold and go into a smaller space. It's like that with things like air and water. When you warm them up, all the little things that the water and air is made up of, called atoms, the little building blocks, they start moving around faster. Well, if they're moving around faster because they have more energy from the heat, from being warmer, they need more space. You can take a gym of second graders who are cold and shrink the gym down really small because they're not moving around a lot. But if they need space, you've got to make it bigger. And that's why warm things rise, because they're moving faster. So you got to give them more space, which changes their density. Things that are more dense are more compact, and they'll sink below things that are warmer in temperature and can expand. So when you have an air balloon and you put warm air in from the bottom, are you doing anything yet? Oh, it's got a couple. We'll check back with that in a sec. When you put warm air in from the bottom, it takes that air inside and it expands it, giving the air molecules more space to move because they're moving faster. And that in turn will act almost like a bubble. Cold air down below, warm air above, and it will cause it to rise as it expands. Because things that are less dense have more room and more open space, and that causes them to float on top of other things. So this experiment, failure, didn't work. I've got 6 minutes. I'm going to try it again with something else. Maybe it's because I used distilled water. I know the Coke and Mentos experiment works because the Coke forms on the sugar of the Mentos and causes the bubbles. So maybe I need real water, regular tap water to make this work. Let's try that. I'm going to go to my sink over here and get some tap water. And since I'm out of vegetable oil, I've got this other thing called mineral oil. This is the way I was going to change my experiment, by using a clear oil. But we're going to do two things at once because that's crazy. Oh. Safe science. Let's pour that mineral oil in. Oh, it's even globbier than the vegetable oil. That's so cool. And since I own this bottle of mineral oil, I can use as much as I want. Glug, 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 glug. And I'm going to add a lightweight color this time, because the green, which it is doing it a little, it lets a bubble up every now and then, but the green was too dark. You couldn't see anything. So I'm switching to yellow, and I'm going to do a drop of yellow. Just a couple of drops. Here we go. You ready? Oh, look at that yellow falling down into the water. So apparently it's still the same thing. Oil is less dense than water, so it floats. It's got more room for its stuff. Those bubbles of yellow, hopefully they'll pop and go into my water. If not, I can use my straw again. There we go. Doop, 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 doop. Just popping those bubbles. All right, now let's try adding my Alka-Seltzer, a new tab, because I don't want to go digging into that other one. See what happens. See if I can get this experiment to work so that these kids aren't like, wow, this guy. Plop, plop, plop. And go into the water. There we go. Oh, they're fizzing now. Maybe that was it. Maybe I just needed that regular water, not distilled water. Oh, here goes our first one. Here goes some yellow ones. They're going to start going up into the, they're fizzing a little. Maybe it's just old Alka-Seltzer. This is the problem with live stuff, is it doesn't work. Try to mash it up a little. So what's happening is, or what should be happening, let me tell you what should be happening. The fizzes from the bubbles from the Alka-Seltzer form kind of a bubble layer around the yellow water, and that bubble carries it up to the top through the oil, because gas or air, or this kind of gas, is less dense than oil. So it will bubble up. Now, when it hits the surface, that bubble around the water will pop, and the water will sink back down. You'll get this continuous thing going, which is not going right now. I'm sorry, kiddos. This worked yesterday, which is weird. It worked I tried it out in my classroom yesterday and it worked. It is neat to look at though. That clear oil on the top and the water moving around below. But the Alka-Seltzer's not doing a thing. We do have some bubbles. Anyways, I've only got 3 minutes left, so I want to recap real quick and then answer a couple of questions. So, good example of how science sometimes doesn't work, but I guarantee you, if you try it at home, you could probably get it to work. And it's a really cool looking lava lamp thing. So, best part of the day, straw rockets. Take a little bit of science, turn it into a game, have some fun with it, be safe, but have some fun with it. Maybe decorate them, draw on them, have a contest, see whose rocket goes the farthest, see who can spin the most, see who can hit a target, but have a good time with it. Okay, you have vacation coming up. Are there any questions anyone would like to ask about anything in science? Maybe I can answer it.
There was one question about what makes birds fly if they don't have those kind of same things as rockets.
How do birds fly? That's really cool. So, to put it simply, the way a bird's wing works is by flapping it up and down, it makes the air, they kind of push off of the air almost. When they push their wing down, it pushes them up. If you ever see a bird fly away from you, you see them almost bob while they're flying. The air pushes down, but also the way their feathers work is kind of like what we talked about with the straw rockets. When a bird is flying, the feathers create almost like different ways that the air moves by them below and above, which helps to lift the bird up a little bit, kind of like the way a plane works. A plane's wings are shaped different on top than they are on bottom to get the air on top to be different than on the bottom. And it causes the air to push, almost like that rising effect of temperature, but without the temperature. So birds do that. Their feathers are shaped and their wings are shaped in such a way that the air above is different than the air below, causing them to naturally rise. And the way they push off of the air, kind of like when you're swimming. Plus, their bones are like hollow and very, very lightweight. Birds weigh like almost nothing. They're so light that there's not a lot pulling them down to the ground. So birds fly by pushing off of the air and causing their wings to give them a little bit of a rise. What else we got?
Well, then we just had the question about the hot dog and the hamburger, I think it was, and the consensus was hot dog was the favorite between the two.
Between hot dog and taco?
That's what it was. Sorry, I'm sorry. Taco, yes.
Guys, I really like tacos. I don't know. Maybe it's because you're younger, but tacos, it turned into a holiday. We've got Taco Tuesday. You can, I mean, I did have hot dogs last night, but I mean, experiment with your food, by the way. Turn your hot dog into a sandwich. Use a hamburger roll, maybe instead of a hot dog roll. Maybe use a wrap. Roll your hot dog into a wrap and make it into like a taquito type thing. Well, kiddos, I am out of time. I had one experiment that worked great, a straw rocket. I showed you how to modify it with wings and how to curve the wings to give you farther distance. That's science. It doesn't seem like it is, but it is science. I showed you an experiment that didn't work. Look it up on YouTube with your folks, though. Homemade lava lamp. Guarantee it works most of the time, just not for Mr. Dufour right now, but it did make a cool wavy type thing. And if you're interested in any other videos, I do run a YouTube channel called The Demo Lab. We do a lot of fun stuff on there, so you can check that out. And make sure right now, during this crazy world that we live in, you get outside, you get some fresh air, and you have some fun with science, because that's what it's all about.
All right. Thank you very, very much, Mr. Dufour. That was amazing. I learned some new stuff that I'm definitely going to try out with my kids. So thank you very, very much. And if you have a chance, make sure to head over to Mr. Dufour's YouTube page. You definitely will not be disappointed.
Have
so
a good
with
rest
that,
of your year.
yes, take care, everyone. Bye-bye.